Hi, today we talk about atomic structure. These pictures show us how scientists think the atom look like these days. But before that, we need to know how did scientists in the past used to think about the atom. Developing theories that talk or explain the atomic structure started long time ago. The first one or the first person to start talking about the atomic structure was Democritus. Democritus decided that if we have a stone and this stone was continually being cut into smaller and smaller pieces, then at some point there would be a piece that won't be able to be divided anymore. Democritus called this part atom, where the letter A means no and tom means divided. After Democritus came Aristotle. Aristotle didn't believe in Democritus' atomic theory. He believed that any kind of matter on Earth was made of four specific elements: fire, water, air, and earth or dust, with different ratio, of course, from one kind of matter to the other. And because of this theory, he also believed that cheap metals can be converted into precious metals by changing the ratio of these four elements. After 17 centuries of Aristotle's atomic theory came Robert Boyle. Actually, in the past, theory came first, then they started to find the facts that support the theory. But with Robert Boyle, another era has begun. Facts come first. Actually, Boyle refused the four-element theory. He made his own lab and started experimenting. He gave the first definition of the element. He said that any substance that cannot be broken or divided into two or more other substances, it's called element. And then came John Dalton. Dalton's theory is considered a foundation of the modern chemistry. Dalton based his theory on two laws. The first law is the law of conservation of mass, which states that matter neither be created nor be destroyed in a closed system. Let's examine this chemical equation. We will find that we have 4 iron atoms in the reactants, 4 iron atoms in the product. I have 6 oxygen atoms in the reactants and 6 oxygen atoms in the product, 3 carbon atoms in the reactants and 3 carbon atoms in the product. The second law, which Dalton based his theory on, was the law of constant composition. This law states that in any particular chemical compound, any sample of this compound will be made of the same elements in the same ratio or the same proportion. For example, if we have one molecule of methane, this one molecule of methane will always contain one carbon atom surrounded by 4 hydrogen atoms. And now to Dalton's postulates. The first part of Dalton's theory is that each element is composed of solid, tiny particles that cannot be divided anymore. Each particle is called an atom. Dalton's second part is that atoms of one element are identical in mass and properties. Let's examine this. This is oxygen gas and this is chlorine gas. Oxygen gas consists of oxygen atoms. They are all similar to each other. Chlorine gas also consists of chlorine atoms and they are identical to each other. But oxygen atoms differ than chlorine atoms in terms of mass, volume, and other chemical properties. The third part of Dalton's theory or Dalton's postulate is that if an element is formed of identical atoms, then the compound is formed of different atoms with the same ratio. Let's examine this picture. This picture represents molecules connected together, and these are water molecules. Water molecules always consist of 2 hydrogen atoms with 1 oxygen atom. The same ratio, but different atoms here. Hydrogen atoms and oxygen atoms. Also, if we take a look at this picture, it represents the sulfuric acid molecule. The sulfuric acid molecule consists of 3 different elements: sulfur, oxygen, and hydrogen. At the end, Dalton considered the chemical reaction as an arrangement of atoms to form new molecules, new substances.